Hi, and welcome back to class of Product Development and Entrepreneurship. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lectures 15, Design for Assemblies. The learning outcomes of these lectures is to learn the basics of design for assemblies, which are the methods used for the assemblies, and which guidelines we have to follow while we doing the design for assemblies. So let me start today's lectures, that is design for assemblies. As we know that sale price is equal to production cost plus profit. It is nothing but the summations of production cost and profit. And we all know that today is the competitions world, and due to the globalizations of business, if we have to sustain in the market, we have to reduce the production cost. So to reduce the production cost, we have to implement design for function. And design for functions like design for manufacturing, design for assembly, design for maintenance, design for environment, etc. So that we can reduce the production cost, and we can optimize our price. So here in up to these lectures, we learned the design for manufacturing, design for maintenance, and what are the guidelines followed by for the design for manufacturing and assemblies. So in these lectures, we learned the design for assemblies and which are the guidelines we have to follow for the design for assemblies. So what is design for assemblies? So design for assembly is the process by which the product is designed so that so that the assembly of that component or easily done. So design for assembly is a tool used to assist the design engineers in their product designs, and that will be transitions to minimum production cost, focusing on the number of parts and easily handlings and assemblies. So the functions of design for assemblies, or you can say the design for assemblies, concentrate on sorry, first, reduce the cost of assemblies. Second, improve the quality and reliability. Third, reduce part inventory. And fourth is the reduce productions equipment. So mainly focus design for assembly is focus on these four functions. First is reduce the cost of assemblies, improve the quality and reliabilities, and reduce third is the reduce the part inventory, and fourth is the reduce productions equipment. So if we have to learn the design for assemblies, we must be know that which are the methods used for the assembly of component. So let's first start understand the methods which are used for the assemblies. So if we look at the assembly methods, there are three methods. First is the manual assemblies. So assembly is done by the laborers or workers. And second is the fixed automatic assemblies, and third is the flexible automatic assemblies. So based on the assemblies methods, there are the variations in design for assembly guidelines. So let's start the guidelines for the design for assemblies. So as we know that what is the purpose of design for assemblies? The purpose of design for assembly is to reduce the part of particular products, and it makes like assembly can done easily. So the guidelines which have to follow for the design for assemblies, that is general guidelines for design for assembly, that is first thing is the minimize the part count. So as the number of part is less, we can make the simple assemblies. Second is the prefer self-locating parts. Third is the use standardized to reduce part varieties. So we have to use the standardized parts to reduce the varieties. Next is maximize the part symmetry. So as our part is symmetry, we no need to orientations when we do the assemblies of that particular parts. Next is prevent nesting of parts. So when the part is stored there, we have to design the parts that cannot nesting, and design the mating features for easy insert. So whenever we have to design the parts, we have to given the mating features, so we can easily insert the parts when we do the assemblies. And next is the eliminate fasteners. We have to avoid the fasteners whenever it is not required. So as we know that the drivings of screw is more expensive than the cost of screw. So we have to avoid or eliminate the fasteners in our products. Next is ensure sufficient space between fasteners and other features for the fastening tools, and prefer easily handling parts, so we can easily handle the parts during the assemblies. Provide the alignment features. So these are the basic guidelines for design for manufacturing, design for assemblies. And if you look at the methods of assemblies, there are three methods. First is the manual, second is the fixed automatic methods, and flexible automatic methods. So based on the assembly methods, there are the guidelines for the design for assemblies. So guidelines for the manual assemblies are first is the eliminate the need for the worker to make the decisions or adjustment. So whenever we know that in manual assembly is done by the worker, so when the worker do the assemblies, there are no need to any guidance. Second guidelines is ensure accessibilities and visibilities. Third is the eliminate the need for assembly tools and gauges. So when we have to do the assemblies, there are no requirement of any assembly tools and gauges. That means what? Prefer the self-locating parts. And next is the minimize the number of different parts. So part varieties we have to reduce according to the design for assemblies. And next is avoid part orientations during assemblies. So we have to avoid the orientations of parts. So we have to make the symmetric object, so we can avoid the part orientations, because we know that in symmetric object we haven't required the orientations. And prefer easily handles parts that do not tangle or nest within one another. So we have to design the parts that parts cannot be tangled or nested when it is stored or when it is in bulk size. So these are the guidelines for the manual assemblies. Now next is the guidelines for the automations assemblies. So guidelines for the automations assemblies, that is use, as we know that in automations, so all assemblies is done automatically, and according to these automations we have to design the parts for our products. So first guidelines for the automations based on the DFA, that is use self-alignment and self-locating features. Second is use the largest and rigid part as a base of assemblies. So we have to choose the base of that assemblies, that part which has the large space and have a sufficient rigid. Next is the use the standard components and materials. And next, avoid the part that require the orientation. So we have to avoid the parts that require the orientations. We have to make the parts as symmetrical as much as possible. Next is use the part that can be fed automatically. And the last is design part with a low center of gravity. So we have to keep in mind that when we do the design of components, the center of gravity must be low. So these are the guidelines for the automations according to the design for assemblies. So here I shows the some designs rules pictures according to we learned in previous slides. So here the first rules is based on the symmetrical objects. So as we explained, we learned in previous slide. Third is the provide the features that prevent the jamming of parts. That in third rules, if you look at the pictures of the third rules, there are in bottom slot is provided, so it cannot jam. And fourth rules, if you look at, there are the avoid features that allow the tangling of parts. So here you can see that the figures, there are the parts. First part is that can tangles with one another when it is stored. So we have to avoid the such type of parts when we do the designs for the according to the design for assembly. So it can be reduce the assembly times and also the reduce the assembly cost, and it is directly effect on the production cost. So in these lectures we learn the design for assemblies and which are the functions of design for assemblies, which method is used to assemblies, and based on that methods which are the guidelines for the design for assemblies. Thank you.